Section 15, finding absolute extrema. So absolute extrema sounds scary. They're just the highest and the lowest points on the interval. And it's absolute because they are the absolute highest and the absolute lowest. Compare that to relative, which was in the last section and also in this picture. And this is a relative minimum because it's higher on either side. It's going up on either side. However, this is actually the lowest point on the interval. So we'd want to ignore this guy and grab this guy. And we're going to be doing this without graphs. We're going to be analyzing functions to come up with these values. Which means we're just going to be testing all of these points in our original function just to see which one's the highest and which one's the lowest. So all we have to test is critical points, so where we have relative minimums or maximums, and endpoints for our highest and lowest. Notice in the picture that the endpoint on the right was actually the absolute maximum. And this could happen in a lot of cases, so you'd need to check both the endpoints and the critical points. So first thing we'd have to do is find the critical points. So the derivative of 2x over x squared plus 1, let's test those quotient rule skills. Bottom d top minus top d bottom all over the bottom squared. Okay, I have a fraction here. First thing critical point wise I would check for is where is this bottom discontinuous? Like, can the bottom be 0? And the answer is no, because x squared is always positive, plus 1 is always bigger than 1, so we can't get a 0 on the bottom, which is good. So all we have to do is check where the top is equal to 0 now. So I'm just going to set up a new equation where I say, hey, where is the top? So 2 times x squared plus 1 minus 4x squared. Where is this equal to 0? And this shouldn't be too bad to solve. I get 2x squared plus 2 minus 4x squared equals 0. I can combine those two terms and I get negative 2x squared plus 2 equals 0. So I get negative 2x squared equals negative 2. I divide both sides by negative 2. I get x squared is equal to 1. That was nice, because now my x is just plus or minus 1, which is a bad way of writing it, so we actually have to go down here and write it as x equals 1 and x equals negative 1. So remember, this is kind of a bad way of writing it, so we rewrote it down here as like the two possible answers. Alright, all we've done is identify candidates to test for the absolute extrema. The other two candidates are the endpoints of the interval, negative 2 and 2. So the points I'm going to test now are negative 2, negative 1, 1, and 2. The negative 1 and 1 coming from our critical points in our function, and the other two coming from the endpoints of our closed interval. One thing to note, if you get critical points that are not on your interval, so not in between negative 2 and 2, you do not look at them. You do not test them. You only test things that are on your interval. It turned out in this problem that both of our critical points happen to occur in our interval, so we have to test both of them. But you don't always have to do that. Now we're testing these in our original function. So I'm going to get negative 2 times 2 on top. So I'm testing them in the original function, this guy, over negative 2 squared plus 1. And so here I get negative 4/5. All right, negative 1 time. On top I just get negative 2 over 1 plus 1, so that's negative 1. Next, 1, I get positive 2 over 1 plus 1, and that is 1. And 2, I'm going to get 4 over 4 plus 1, which is 4/5. So all I did was plug these numbers back into the original equation. Now all I have to do is pick which one's the highest and pick which one's the lowest. Oh, that one's the highest, that one's the lowest. So our absolute min happens at 1, 1. Or -1, -1. Whoops. And our absolute max is at 1, 1. Those are some nice answers. So all we did was look for the absolute highest and absolute lowest value of this function on the interval. And this is something we can evaluate without the use of a calculator or a graph using calculus. And that's it for this section.